Section 4.4 starts on page 173, and it is another part of congruence criteria for triangles. And it is two more additional theorems that we can use to prove that triangles are congruent. So let's jump into it. On page 173, take notes of these two theorems. The first one is angle, side, angle. That essentially is the opposite of side, angle, side, but the same principle. That if you have two angles that you know are congruent, and their included side, so now the side in between the two angles, then the triangles must be congruent. That is an angle, a side, and an angle. If we know those things, triangles are congruent. Next one is angle, angle, side. This is our last triangle congruence theorem, and it is exactly how it sounds like. If we know the two angles and then the next side are congruent to each other in two triangles, then the triangles must be congruent. And that is the non-included side of one of the sides. So if we have two angles, what we got here, and the non-included side of one triangle are congruent, then the two triangles are congruent. So an angle, and then a side. And this section is just going to be practicing those two things, just like the last section was. And we are actually going to completely jump to example 3 and start applying this theorem, these theorems. All right, example 3, we apply the angle, side, angle, ASA, congruence criteria. And we're going to use these figures. I know mine looks a little bit different than yours. So here we go. Part A, let's investigate these 3 triangles. And I see that we've got congruent angles, some congruent sides, and let's see what Part A wants us to do. Part A wants us to know are JKL, this triangle, and MNO congruent. So we're not using this one. I'm going to cover him up not to confuse myself. Let's look at these 2 triangles and see. We have an angle, an included side, and then another angle in both of them. And that's exactly what angle, side, angle is a side sandwiched between 2 angles. That theorem tells us that if we know those angles and sides are congruent, then the triangles must be congruent. So, A, are they congruent? Yes. Why? We have 2 angles and the included side. All right, like it. I bet part B uses this triangle, so let me uncover it. Let's see about B. Are JKL and PQR congruent? So we're not using this middle dude. Let's look at them. JKL we had already looked at, and we know that it has 2 angles and an included side. But let's look at PQR. PQR does have 2 angles that we know are congruent to these 2 angles, but it's telling us that this side is congruent. Is that enough information to know that these 2 triangles are both congruent? No, it's not enough. Because we need to know the same thing about both of the triangles, and right now we don't know the exact same thing about both of them. We cannot be sure that they're congruent. So we would say no, that we don't know if they're congruent. We can't say for sure. And that's because here in that triangle, QR is not the included side. And that's what information we have for JKL. There isn't enough information to tell if they're congruent. We would need to know that QP is congruent to JK. But we don't know that, so we can't say for sure. Let's keep practicing this with example 5. Let's use this triangle congruence criteria, keep practicing it. Example 5a gives us two triangles. We know one angle is congruent, angle A and angle D. We know one side is congruent, AB and DE. It says what additional information is needed to show that ABC is congruent to DEF by angle, side, angle. So it tells us what to use. Angle, side, angle means we need a side sandwiched between two angles. Let's look at what we've got. We've got a side and we've got an angle for each one. So if we want to use this angle, side, angle theorem, then we're going to need this angle that sandwiches them together. So what we would need to know is we would need to know that angle B is congruent to angle E. Once we know that, we could prove it. That's that additional information we would need. Let's look at B. I put B way too far down. Sorry. I'm going to write it out here. That way we can still see the figure. I did not think that through. What additional information would we need to know to prove that the two triangles are congruent by angle, angle, side? Okay. Angle, angle, side means you've got two angles and then a side. So we would need, if I wanted angle, angle, side, that would be angle C, angle A, then the side. That'd be angle C and angle F, angle, angle, side. So we would need that angle F is congruent to angle C, or C is congruent to F, it doesn't matter which way you do that, in order to prove it by angle, angle, side. All right. Let's put this all together with example 6. Oh, just kidding, I forgot we had a proof. This is not in your workbook, but I wanted to go over this just as another proof example. This is actually a main example from the textbook, and it is, in this example, you're going to try and prove that FH, so this side, is congruent to JL, this side. You want to prove that those two things are congruent, given what they have. And they tell you that we see that this side is congruent to this side, and we've got two angles. So you can already probably see in your head, we've got, what do we have? What triangle theorem do we have? Well, let's see if you're right. So the first statement's going to be that we know angle F is congruent to angle J, G is congruent to K, and then that side is congruent, and the reason's going to be it was given. You guys can write this down if you want, or you can just reference it later if you need help with proofs. So the next thing we're going to be able to naturally determine is that those two triangles are congruent. What theorem did we just learn that can prove that those two triangles are congruent? The angle, angle, side theorem. Because that is an angle, and then a side. Angle, angle, side. So we know that those triangles are congruent, which is really helpful in establishing the triangle congruence, because then, ending the proof, those two sides have to be congruent to each other, FH and JL, because corresponding parts of congruent triangles are congruent. And that's kind of going to be how a lot of those proofs are, is you're going to need to prove that the triangles are congruent using one of these congruence theorems. And then, because of this CPTC, I can't say that, CPCTC, so easy to get tongue-tied. Because of that, any other part that you need to know is there. Okay, now we're jumping to example 6. Example 6 kind of throws it all together, and it tells you that this polygon ABCD is congruent to this other polygon EFGH, and it wants you to find the value of x. The only main thing you have to know is that if these two polygons are congruent, that is a very important statement, then all of their corresponding parts are also congruent, And we can see that based on looking at this figure, that means that side AD is going to be congruent to side EH. And from there we could solve to figure out what x is, because we know AD is 9 meters, and that means it is equal to this 2x minus 3. So we can solve that, and we can find that x is equal to 6. And the only main thing you needed to know here was, once you know that this is congruent, their corresponding sides are congruent, which means that 2x minus 3 is equal to 9. All right, you guys, that was our very last lesson. That is section 4.4.